Imagine a world where invisible forces govern magic-like phenomena all around us, light blinking on and off, electricity powering our cities, magnets pulling and pushing. For centuries, people wondered, are electricity and magnetism related? How does light travel through space? The answers to these mysteries wouldn't arrive until one extraordinary man wove them together through the power of math. The man behind the magic, James Clerk Maxwell. Born in 1831 in Edinburgh, Scotland, James Clerk Maxwell was a curious boy with a love for mathematics and science. By the time he was 14, he published his first scientific paper, a hint of the genius to come. Maxwell studied at Cambridge University, emerging as a brilliant mathematician and physicist. In the mid-1800s, scientists had discovered many surprising facts. Electric charges create forces, Coulomb's law, magnets have north and south poles, and changing magnetic fields can induce electricity, Faraday's law. But these findings felt like pieces of a puzzle, disconnected and mysterious. The quest, Maxwell's brilliant insight. Maxwell's goal was to bring all these discoveries into a single, elegant framework, to reveal the hidden connections between electricity, magnetism, and even light itself. From 1856 to 1865, Maxwell worked tirelessly. He translated Faraday's experimental observations into mathematical formulas, invented new concepts like the displacement current, and finally wrote down 4 equations that described all known electromagnetic phenomena. In 1865, Maxwell stunned the world by showing that light is an electromagnetic wave traveling through space at a fixed speed, the speed of light. One stormy night, Maxwell dreamed he entered a giant ancient hall. In the center was a glowing scroll floating in the air, but it was locked by 4 symbols. A voice whispered, "To see the truth, you must face the 4 guardians." The first door opened, and from the light emerged the guardian of electricity. He held a shining sphere of charges, and said, "I am the law of electric fields. All charges create electric fields, and the total field around me is equal to the charge inside." Suddenly, the scroll lit up with the first symbol. Nabla times E equals, rho/epsilon naught. The ground shook, and a second door opened. Out came the guardian of magnetism, carrying a steel ring that looped forever with no start and no end. His voice was heavy like thunder. "Unlike charges, magnetic poles cannot exist alone. My field lines always loop, they never break." And the scroll revealed the second carving. Nabla times B equals 0. But the hall grew darker, and a crack of lightning split the sky. The third guardian appeared, cloaked in blue flames, the keeper of changing fields. He raised his staff and said, "When magnetic fields change with time, they give birth to electric fields that swirl endlessly." The scroll burned with the third truth. Nabla times E equals, minus, del B/del T. Maxwell trembled as the last guardian rose, taller than all the rest, with coils of light wrapped around him. He was the guardian of Ampere and Maxwell, the unifier. His voice echoed like 1,000 drums. Electric currents, and even changing electric fields, create magnetic fields that circle around them. The final symbol appeared, glowing brighter than the sun. Nabla times B equals mu naught J plus, mu epsilon naught, del E/del T. The hall blazed with light as the scroll unlocked. Maxwell opened it and gasped. The 4 guardians together revealed that electricity and magnetism were one, and even light itself was an electromagnetic wave. The hidden scroll of the universe had been read at last. Maxwell's equations told a story of unity. Electricity, magnetism, and light are all part of the same electromagnetic symphony vibrating through the universe. Thanks to Maxwell's vision, modern technologies were born, from radios and TVs to lasers and Wi-Fi. His equations predicted radio waves even before their discovery, linking physics and everyday life. Maxwell passed away in 1879, but his legacy lives on in every flicker of light and every signal sent across the globe. If this journey lit up your mind, then light up our channel too, like, share, and subscribe to join us as we uncover more hidden stories of electricity.